Jai Hind dear students, I am Dr. Preeti Mittal and in this video we are quickly going to revise the small type topics from light chapter that we haven't covered in the previous videos. So starting with diffraction of light. Earlier it was believed that the light travels only in a straight line and that is why it can cast a shadow. Casting a shadow shows the straight line pathway behavior of the light, means it shows that the light travels in a straight line only, it is having a particle nature. But later on it was proved that the light has the dual nature, it has wave nature also, which was proved by quantum theory of light, and that you will be studying in your higher classes. But what is diffraction of light? Whenever there is any very small opaque object in the pathway of light, then the light cannot travel in a straight line. Then the light ray bends around the margins of that small obstruction and continues to move forward. This phenomenon of light of bending around a small pathway and around a small obstruction is known as diffraction of light. Next comes the laws of reflection. There are two laws of reflection that you should know. The first law of reflection states that the angle of incidence and the angle of reflection are always equal to each other. Whatever is the angle of incidence, that is the same as the angle of reflection. And the second law states that the incident ray, the normal, and the reflected ray all lie in the same plane. Okay, I'm not going to into the explanation of each and every point, but we are just quickly revising everything. Based on this law, you could be having one question in your exam that if it's a plane mirror, and you always know that the angle of incidence is equal to angle of reflection, and if this is the normal, this is the incident ray, this is the reflected ray, and if this angle is 50-degree, what is the angle of reflection? So what will be the angle of reflection? Here the angle with 50-degree that is given is not the angle of incidence. The angle of incidence is the angle between the incident ray and the normal, and this angle will be, the whole is 90-degree, so this angle will be 40-degree, and so the angle of reflection will also be 40-degree. Okay, so it's very simple question, but don't get confused. Next comes the refraction of light through a glass slab. So when the light ray is entering from one medium to another, there is refraction of light, that is bending of light. Why this bending of light occurs? Because when light enters from one medium to another, its velocity is going to change. Each and every word of this video is really very important, so pay very well attention. Okay, so when a light ray is entering from a rarer medium into a denser medium, the velocity of light is going to change, and that is why it will not continue in a straight line, but it is going to bend its pathway. So when it enters from a rarer medium, that is air, into a denser medium like glass or water, the light ray is going to bend towards the normal. It's going to bend towards the normal. This is the incident ray, this is the refracted ray. Okay, now when this refracted ray will come to the other surface of the glass slab, means it's going to emerge out. So before emerging out, here again if we draw the normal, that is an angle of 90-degree with the surface, then we'll observe that since the light ray is going from a denser medium, that is glass, into air, that is the rarer medium, this light ray is going to bend away from the normal, and this ray that is emerging out is known as emergent ray. Now if we continue, if we draw this, extend this forward, the incident ray, and we just compare it with the emergent ray, we will find that the light ray has shifted towards one side. Okay, the emergent ray is parallel to the incident ray, but it's laterally shifted. So this shift of the emergent ray as compared to the incident ray is known as lateral shift. This shifting of the light ray when it passes through a glass slab, this shift is known as lateral shift. Okay. Now, next are the laws of refraction. Refraction, you all know that when a light ray enters from one medium to another, the light ray is going to bend. So we are going to see about the laws of refraction. Okay, laws of refraction. The first law states that the incident ray, the refracted ray, and the normal all lie in the same plane. It is the same as that was in laws of reflection also. Okay, and the second law of refraction is the Snell's law. According to this law, the sine of angle of incidence, the ratio of sine of angle of incidence to the sine of angle of refraction, refraction is a constant for a particular color of light and for a particular pair of medium. And this constant is known as the refractive index, and this is the Snell's law. Okay, so Snell's law is very important, remember that. Okay, don't just write this formula and believe that you are going to get full marks. Write the complete law fast in your exam. So I'm just repeating this law. According to Snell's law, the ratio of sine of angle of incidence to sine of angle of refraction, that is always a constant for a particular color of light and for a particular pair of medium. This is known as Snell's law. Now, based on refractive index, what is refractive index? This is known as refractive index. And based on refractive index, you could be having some numericals in your exam. I'll be just telling you the example of one numerical, but that one numerical will be enough to be to be having a concept clarity. Okay, so don't at all bother about any of the questions from the refractive index if you are clear with this concept. Now, refractive index of any particular medium. Suppose I'm talking about refractive index of glass. So refractive index of any particular medium, say, let's take an example of glass. It's equal to speed of light in vacuum, speed of light in air or vacuum. We approximately take it the same. Exactly, it's not the same, but we take it for doing the calculations, we take it the same only. Okay, so speed of light in air upon speed of light in glass. That will give you the refractive index of glass. Suppose you have to calculate the refractive index of water. So refractive index of water is equals to speed of light in air upon speed of light in water. Okay. Now, speed of light in vacuum, you have to remember that value. That will never be given in the question. Okay. That value you have to remember. So if the speed of light in vacuum is 3 into 10 to the power 8 meter per second. That you have to learn by yourself. That will not be given in the question probably. Okay. Suppose it's given that the speed of light in glass is 2 into 10 to the power 8. And you are asked to calculate the refractive index. Then what will be the refractive index? 10 to the power 8 will be getting cancelled out with each other. We will be left with 3 upon 2, and 3 by 2 is 1.5. What will be the refractive, what will be the unit? Refractive index doesn't has any unit because meter per second and meter per second will both be cancelled with each other, and so the refractive index is not going to have any unit. Okay, so the speed refractive index of glass is equal to the speed of light in vacuum actually upon speed of light in glass. And if the refractive index is given and you are asked to calculate the speed of light, that also you can do. Okay, so one of the values, either a refractive index or the speed of light in that particular medium, that will be given to you, and another value will be asked to you. Okay, I hope you will be easily able to work it out. Next and the last topic is power of the lens. So quickly, When you go to a doctor for a checkup, the doctor prescribes you a lens if you are having some visual errors. Then the power of the lens is mentioned on your prescription. Okay, you might be having a power of minus 0.5, or your power could be plus 2.5. Okay, varying from person to person. So what is this power of the lens? The power of the lens is 1 upon focal length in meters, or you can say 100 upon focal length in centimeter. You can be having a question based on power of the lens in your exam. So you can use this formula to calculate the power of the lens. Remember, if the focal length is negative, then the power will also be negative. So in case of concave lens, the power will be negative. And in case of convex lens, since convex lens focal length is positive, so the power will also be positive only. Okay. Now, last is the combination of focal length. You must have observed that when a doctor is checking you, he keeps on putting one after the other lenses in the eyes. They are having some special spectacles for checking the eyesight, and when they are checking your eyesight, they are putting one after the other this lenses in front of your eyes only. Then how they are going to calculate the total power of your eyes? So that total power of a combination is just the sum of the individual powers. Okay, any number of lenses that the doctor puts. Okay, so suppose if P1 is 0.5, P2 is 0.3, and P3 is minus 1.5, then it will be having a total power of, let's say it's suppose 0.5 only. No, not 0.5, 0.2 minus 0.2. Okay, 1.2 it will be very high, na? It will just cancel out all these things. So what will be the total power of the lens that will be required by that particular person? It will be 0.8 minus 0.2, that will make it at 0.6 diopter. Power is expressed in diopter, represented by D. Okay, and whenever you have to find out the total power of the combination, you just can find out the individual powers, just add them up, and you will get the answer for the total power. Okay, so I hope we have covered with each and every topic of light chapter. We have seen the ray diagrams in the previous videos. I have discussed the numerical tips for you all, so that you can easily work out the numericals from the light chapter. And in this video we have discussed the remaining topics as well. Okay, so that's all for today. Keep preparing well for your exams. Good luck everyone.